Hi and hello everyone. So for today's video, we are looking at the resultant vector. We want to find the magnitude and direction of resultant vector. Let's say we have this problem, example 1.3. We have two people, Malik and Joe, are pulling a box. Malik pulls with 120 Newton and Joe pulls with 100 Newton as shown in the diagram. So here, so Malik pulls 120 Newton above 30 degree above positive x-axis. Joe pulling 100 Newton below 45 degree below positive x-axis, and the questions want the combined or resultant force and its direction. So we will be calculating resultant vector. We want the magnitude and its direction. So the first step, you have to draw axis for each vector. So I have two vectors over there. So this is for Malik. So Malik pulls 120 Newton at an angle of 30 degree and Joe pulls 100 Newton at an angle of 45 degree. So to find the combined force, we need to find the summation of the forces on x and y component. Okay, so we have this column force. We have, let's say Malik is F1 and Joe is F2. So I have F1 and F2 row. Then below you have to put the total forces. So here is your resultant force, total forces on x component and your total force on y component. Okay, so for F1, like what we have been discussing before, we take out the triangle, here 30 degree. So we have F1 120 as the hypotenuse. So the vertical one is y component and the horizontal one is x component. So for F1 x component, it is adjacent to the angle. So we will be using cos 30. So hypotenuse is 120. It is positive x. And y component, we have the vertical one. It placed opposite to the angle, so sine 30, and the hypotenuse is 120. Okay, so for F2, we will be using this triangle, 45, 100. So the vertical one is y component, this is x component. Okay, both for F1 is positive because this quadrant, positive x and positive y. So for F2, your x component is adjacent to the angle, so cos 30, hypotenuse is 100, positive because this quadrant to the right. Okay, for F2, y component opposite to the angle, so I will be using sine 45, and here is 100, the hypotenuse negative because this quadrant y is downwards. If you don't understand why I put the hypotenuse at the front of the cos and sine, look at the previous video on how to resolve a vector. Okay, so to find the resultant force, we need to find the total fx and fy component. So we have to find the value for x component. Total meaning you have to total up all of the forces on the column. Cos 30, make sure you're calculated in degree mode because you are using degree. 30 or 45 over here, sorry. Okay, cos 45, so we will get 174.6337. Before finding an answer, take at least 4 decimal places. 120 sine 30 plus negative 100 sine 45. So this is negative 10.7107. Okay. So, how to find the resultant force or resultant vector? First thing first, you draw your fx and fy on the axis. So, here is my axis, y-axis and x-axis. Okay, so my x is positive, so it shows that the vector is to the right, 174.6337 in length. And my fy is negative, so it goes downwards. Maybe it's a little bit shorter than the x1. So negative 10.7107. Negative means downwards, so let's check it out because we have shown it goes downwards. So we know that the resultant between two forces is in the middle. It's not in the middle, it's in between these two vectors. So this is fx, this is fy, and this is f resultant. So you want to find the green line fr. Okay, still using the same concept, trigonometry. Okay, you can choose any triangle you want. You maybe wanted to choose this one or this one, but always choose the one with respect to x-axis, so that when you want to find the angle of the resultant force due to x-axis, it will be easier for you because you have using this one. So I will be using this triangle to find my f resultant. So let's take it out. So over here, you know that this one is x 174.6337, the y 110.7107, and this is your fr, and this is your angle with respect to x-axis. So resultant force, this is magnitude of resultant force. So you know that for a triangle, this is, we say, 90 degree right angle triangle. For right angle triangle, fr is hypotenuse. So we know that to find the hypotenuse, we take fx square, total of fx square, this one, plus total of fy square, this one, and we just square root. Okay, like this. This is the general, a square, b square plus c square. So here is your hypotenuse. Okay, that is the general from your maths. fr is equals to 174.6337 square plus negative 10.7107, because it is downwards, and then square root, and you will get your answer. Press your calculator like this. Square. Don't mess up with the square. Square should be out of the bracket. 7107 square. Square root your answer. You will get 174.96 Newton. Okay, so I give it here 175 because I round it off to 175. But it is okay if you leave it with 174.96 Newton. Okay, so that is magnitude. Let's look at its direction. So direction, as I said before, the direction is the angle with respect to x-axis where your resultant vector are. So here is the angle where your resultant vector with respect to x-axis over here. So it is below positive x-axis, but how much degree below the positive x-axis? So because we have the opposite value and the adjacent value, so normally we will be using the value that we calculate before. Normally we don't use the hypotenuse one because the hypotenuse comes from the calculated value. So we want to make it less, we want to make it more accurate, so we use the value x and y that we have calculated before. So we will be using tan because here is opposite, here is adjacent, so tan theta equals to, we have total fy over there over total fx, so theta is shift tan 10.7107 over 174.6337. So press shift tan 10.7107 divided by 174.6337. when you find the angle, you can just ignore the negative sign for Fy. Okay, so we will get 3.51 degree. But you have to explain the direction, so let's put it over here. So the direction for the resultant forces is 3.51 degree below. So because your resultant force is over here, on this quadrant is your positive x, below positive x-axis. Okay, so remember, if you want to find the resultant force, it is convenient if you draw this table and make it 3 column, list out your forces, list out your x component and y component of your forces. Remember to find the total Fx and Fy, and you may use this formula to find the resultant. Just take the total x component square plus total y component square root. You will get the magnitude of your resultant, and from the diagram over here you can find your angle. Remember to draw it because you want to look at the vector whether it is below or above positive x or negative x axis, and then calculate it with your calculator. Okay, so that's all from me. Thank you.